All right, so I think I'm live. I hope I am. Let me go ahead and share this because I had a mistake in my other stream. So let's go ahead. And if you guys are tuning in, I'm just sharing this class to my social media, my TutorU page. So let's go to TutorU. And let's see. Okay, so I think I can get everything all set up now. I should be good to go. Oh yeah, oh no, oh man. Just all different types of things going wrong this morning. That's okay. We will persist. We will push through and we will survive this whole debacle. But we will get going on our inequalities here in just one moment. Let me just get everything all finished up. And oh no. All different types of things going wrong with all of my different stuff. Huh. Okay. We are just about set up. Give me one more moment. What else was I wanting to do? I do not know. What are we doing? Oh yeah, I need to change the thumbnail. This is not a do your homework session. Let's see if I can change this thumbnail easily or if it's going to be a pain in the butt. I think it's going to be a pain in the butt. Edit. Change. I think it's this one. Nope. Oh, I bet it is. Oh, geez. There we go. Okay. Now I have the right thumbnail on everything, so we can get started. Hello everyone, it's Paul with TutorU, and today we're going to be working on graphing and solving inequalities. Graphing and solving inequalities shows up all over the place in your GED 2022 test. You will be trying to figure out all of the different properties of them, right? So you're going to be figuring out if something is less than, greater than, less than or equal to, greater than or equal to, all of those words, all of those different things. It's going to show up on your GED test, and I mean, for those of you that have already taken the GED test or have went through mathematics, they have inequalities. It's very important, right? And we typically don't, like when you think of it, it's only natural, right? You don't learn about inequalities until later on in your pre-algebra classes. And it's a little bit crazy when you think about, you know about equality from the time you learn how to add and subtract, but you don't know about your inequalities, which are as equally of important, if not more important, right? Because most times in the world around us, a lot of the things are functioning off of inequalities and not equalities. Things typically aren't perfectly equal in society or in mechanics or in any type of engineering, but your inequalities are incredibly important. So let me get everything finished set up here. We are going to transition over to our workstation. So, okay, as you can tell, it's a little bit different than normal. Typically I have Typically I have my nice green chalkboard, but I think this looks a little bit better. I think the black, just flat black, looks a little bit nicer. And to avoid overloading people with text when we do definitions, I have figured out a solution to that. So let's go ahead and just define inequalities. Let's figure them out. Our definitions for inequalities. See, look at, I can erase the words. So an inequality states that two algebraic expressions are not equal. Inequalities, not inequalities, inequalities are written with the following symbols. So we have our symbols, and then we have our less than symbol, less than. We have our greater than symbol, greater than, and it directly means these words, right? When you see this symbol, right? Oh, my finger disappears. When you see the less than or greater than symbol, it means that something is less than or greater than whatever is on the other side of it. But we also have this symbol. And notice how this symbol has that line under it. It's less than, but it's also or equal to. Less than or equal to, and greater than or equal to. And then just to go back in, let's just clarify this a little bit more. When you have your, we'll do it in yellow. Think about your less than symbol, right? And if it's or equal to, what that is, look at it, combines these two symbols. When you have the less than or equal to, it is the combination of the equal sign and the less than sign. So less than or equal to, there's our symbol for it. Less than, greater than, less than or equal to, greater than or equal to. Let's see if I can make myself a little bit wider. I can. Heck yeah, look it. So now my arm doesn't disappear and you can see my microphone a little bit. Okay. So inequalities. That's inequalities. We're gonna have algebraic expressions. If you remember what algebraic expressions are, that is a set of, you can have numbers, you can have variables, you can have the combination of variables and numbers, and you can have multiple operations involved, right? So we are going to take a look at, oops, interesting. Oh no, hang on. Let's fix that really quick. I think it's this. There we go. And there we go, that works. So we have our examples of inequalities. The very first one, we have x is greater than 4. Another way of saying that is a number is greater than or equal to 4. 3x plus 12 is less than 15. And another way of saying that is, oh boy, let's see, I think I can get rid of that. There, is 12 added to the product of 3 and a number is less than 15. So 12 added to the product of 3 and a number is less than 15. So there we have our inequalities, right? Two examples. This bottom example, we are able to work with this bottom example because just like our algebraic expressions and our algebra equations, we can solve this. Okay? And what we can do, just for the sake of it today, let's do that. Let's solve this algebraic or our inequality equation here. Let's solve. Do another, just to start off with a nice little example. So we have 3x plus 12 is less than 15. And I might ask you, what is x? What is x? And this is going to be just like solving an algebraic equation. There are a few exceptions to the rules, and I will come up with some examples of those exceptions. So if you are watching, I strongly encourage you to stay tuned, because as we move on, there are two really big exceptions on solving and graphing inequalities, and I will cover those. But I want you to treat it just like it's an equal sign. So treat it like it's an equal sign, except for there are some rules we'll talk about later. So treat it like an equal sign. Oh, I'm off of the screen. An equals sign. Okay, for the purpose of algebra. Okay. So if this was just a normal equation, what would be your first step? Do you remember your inverse operations, your PEMDAS, your reverse PEMDAS, reverse order of operations, or inverse operations? So we have 3x plus 12 on the left-hand side of the less than symbol. How do we get rid of the plus 12? What's the inverse of plus 12? It is a minus 12. And whatever you do to one side of the symbol, you must do to the other side. So although this isn't an equal sign, we still must maintain some level of balance, right? There's always this balance of logic in math, and that's where this comes into play. So we've subtracted 12 from the left side. Now we need to subtract 12 from the right side. And when we do that, let's go ahead. What happens to our 12? That cancels out into 0, but we will not need to rewrite that. And what is 15 minus 12? What is 15 minus 12? That is a positive 3. Then we just drop everything else down. We drop our 3x down, and don't forget about your equality symbol. So, or your inequality symbol. 3x is less than 3. Okay, so we have our variable with a coefficient of 3. So this is our variable. I'll go ahead and underline that in this greenish yellow. So this is your variable. And in red, this is our coefficient. Okay? And what's occurring between the coefficient and the variable? What's happening between these two pieces of our inequality equation? It's multiplication. So multiplication is occurring. Multiplication. Oh, I'm off of the screen. Oh man, my sizing is just so off. Let's see if we can adjust this a little bit. Hang on. I think I can bring this way. And that didn't help any. Oops. Doop, doop, doop. I think, actually, so I need to make it smaller. Stream problems, everybody. All different types of issues. There we go. Get that whole bottom. That'll almost do. We're almost there. There we go. That should work. That should work. So I will finish writing out everything. So we have our multiplication happening between the 3 and the x. So what is the opposite of 3 times x? How do you undo multiplication? You divide. So you divide both sides by 3, and that gives us the solution to this, that x is less than, what is 3 divided by 3? It is 1. Yes, 3 divided by 3 is 1. Now I know, that was just really crazy. Oh, I'm still off a little bit, so I can bring you over. There, okay, everything looks a-okay now. So we have our examples of inequalities, but I want to go through some actual example problems, okay? So let's start with our first example problem. We have 5 times a number is less than or equal to 2 times the number plus 9. What is the solution to the inequality? So first we must write this inequality out. So we have our 5 times a number. What is another way of thinking of 5 times a number? How can we write 5 times a number out? Well, it is 5 and then times a number, right? So 5x. And that is less than or equal to. So less than or equal to 2 times the number. So we'll do that in pink. So 2 times the number plus 9. So 2 times the number. So there's our number plus 9. And now we have our inequality, right? So 5 times a number is less than or equal to 2 times the number plus 9. Does everything look like it checks out? It looks okay to me. So what is the solution to this inequality? How do we go about solving it? And remember, treat it like a normal equation for now. And then we will go over some of the other properties. So treat it like normal. Treat it like a normal equation for now. Equation for now. There we go. So if this was a normal equation, what would you do? How would you first approach this problem? The very first thing that I would do, I would subtract 2x from this right side. We want to combine our like terms. We want to bring our variable and coefficient over together. So we're going to subtract 2x from both sides. And what happens to the 2x on the right side when you do this? You cancel them out. They get rid of each other, right? So, let's see. Hold on. There we go. Okay. So that cancels itself out to a 0. And so what we're left with, what do we have on the left side of the inequality symbol? We have, what is 5x minus 2x? That is 3x. And that is less than or equal to the 2x plus the 2, or the minus the 2x, that cancels out. And we're left with a positive 9 on our right side. Now what do we have to do between what's happening between our coefficient and our variable? It's multiplication, so we must divide. We must divide both sides of the equation. And our 3's cancel out. And what is 9 divided by 3? We are left with our solution of x is less than or equal to 3. Oh, it's one of those mornings. I'm just making all types of word mistakes, stream mistakes. It's just bound to happen, right? We all have those moments. So let's go ahead, and I think what I'll do, I want to talk to you about those exceptions of a rule, of just treating it like a normal problem. So let's go ahead. I'm going to erase everything on this page. I do have more regular examples, but I want to show you the exceptions. So let's talk about exceptions to treating it like normal. So I'll put up here exceptions in inequalities. In inequalities. Okay, and so in any regular equation, so like 3x plus 12 equals 24, you just do everything normal. You subtract from both sides the 12, leaving you with 3x equals 12. And then you would divide both sides by 3, leaving you with x equals 4. But what if we have a negative sign in inequalities? So I'm gonna do this in like our nice aquamarine color. So negative 3x plus 12 is greater than 24. So everything else looks the same, right? For the most part, except for I threw in this negative sign. The only two things that are different, we have our greater than symbol, and we have our equals, right? Between these two equations, those are the only two things that are really, really noticeably different. And that's why this confuses a lot of people, is why do we have these separation of rules with inequalities? And you'll see this, right? So this is the exception. If you write anything down today, this is the thing that you want to write down. So what we're going to do, we're going to just solve this like normal. So how do we get rid of this plus 12 on the left side of our inequality? We subtract 12, and we do that to both sides. Okay, then let's go back, let's rewrite our problem. And so what we're left with is negative 3x is greater than 12, okay? And now in any normal equation, you just divide by negative 3, right? And that is still what we're going to do. We're still going to divide by the negative 3 by both sides. The negative 3 cancels out on the left side. That gives us, it drops down, it simplifies into a 1. Negative 3 divided by negative 3 is 1. And on the right side, what we are left with is, what is 12 divided by a negative 3? That is a negative 4. So we'll write our but, and we have our x. So this is the big thing right here. I want to use yellow, a nice odd looking yellow. You must flip. I'm getting dangerously close, flirting with the edge. You must flip the sign. Okay? Just flip it. Flip it like a pancake, right? So flip it like a pancake. So we have to flip this. And if we were to flip this like a pancake, what direction is it pointing? It is now pointing this way. So it becomes a less than symbol. I'm gonna put a box around this. So we'll put our little arrows, and there. So you must flip that inequality sign. So the answer to this is x is less than negative 4. So why do we do that? We can test this. We can test whether this is true, right? We can test. So all we have to do is pick an x value. Let's go ahead and pick an x value. We have to pick something that's less than negative 4. So what is a number that is less than negative 4? Let's just go with x equals negative 5. And this will be our check step. So check step. And what we will do, we'll go back over into the middle of this screen. We're going to rewrite this problem. So negative 3. And instead of having, let's use that fancy color again. I like that color. That is a good color. And instead of having an x, let's see, there it is. So instead of having the x, we're going to have the negative 5 in there. So negative 3, and then 5. Negative 5 plus 12. And is this greater than 24? Okay. Well, what happens when you multiply the negative 3 times the negative 5? the sign changes, and we're left with a positive 15 plus 12. And is that greater than 24? So what is 15 plus 12? It is 27. And it is greater than 24. So we are good. We have successfully completed the inequality. So that is why you must flip that sign, because when you're dividing or multiplying by a negative number across an inequality sign, it kind of forces the whole equation to flip over, right? Because of that double negative type of rule, right? So if you have two negatives multiplying by each other, it becomes a positive. And when you do this, it fixes everything. So you must do this. This is extremely important. Please remember to flip your inequality sign. Let's see. So I have a couple of people watching, and I appreciate you for doing that. If you are hanging out and just listening, go ahead and hit that like button and subscribe. It helps my channel grow. And I really always appreciate it. I can't even tell you how much I appreciate when I have people subscribing and hitting the like button. It's really cool, especially with me just starting out or restarting. It's very neat. Okay, let's get rid of all of this. Let's clear it out. Let's take a drink of coffee. All right, and we will move on to our next problem. So what is the solution to this inequality? This one won't be as bad. So we're going to write it out as x plus 5 is greater than 4. What do we do in this type of scenario? What's the inverse of plus 5? Inverse operation of plus 5 is a minus 5, and we must do that to both sides. And what happens when you have a plus 5 and a minus 5? It falls off into a 0. What is your 4 minus 5? What is 4 minus 5? That gives us a negative 1. Negative 1 on the right side, and x. So x is greater than negative 1. Would you like to try graphing this problem? How do you go about graphing inequalities? What is a graph? So let's just talk about graphing inequalities. So graphing inequalities. There we go. Bam. That looks fancy. That looks neat. So, x is greater than negative 1. You're going to love graphing inequalities. If you hate graphing regular equations, you will love graphing inequalities. So all you have to do is draw your number line, and let's just put 0 in the middle, right? And I'm gonna actually back up 1. Let's go ahead and use red. So we're putting our 0 in the middle, and 1, 2, 3, 4, 5 on the right, and we'll go 1, 2, 3, 4, 5 on the left. And now we are going to graph the inequality. So can this be negative 1? If x is greater than negative 1, can this be negative 1? That's my big question for you. If you're watching at a later date, I want you to just ask yourself, can I be negative 1 in this? So I'll even write it down. Can we be negative 1? No. No, we cannot. This is not a greater than or equal sign. This is just a greater than sign. So we cannot be equal to negative 1. So on this number line, where is negative 1? Negative 1 is right here. And since we cannot be it, we put an open circle. We put an open circle at negative 1. And what direction are we going? Are we greater than negative 1 or less than negative 1? Greater than is to the right. Greater than is to the right. So we're going to just draw an arrow to the right. And that is the graph for this inequality. A little tip. So let's just draw another quick graph here. So let's just imagine we have our another inequality graph we can do. So 0, 5, -5, and for the sake of our stream, I'm not going to go through and put every single line down. But let's just imagine that our problem is x is less than -1. Okay? Well, what do? We still have our -1 right in that area, and we still do an open circle, right? We can't be -1, but instead of going to the right, we go to the left. And we draw our arrow. That means that it's going out there for infinity. We are continuing out there for infinity. Anything that's less than -1 is going to work for this problem, and that's where things get so interesting with graphing inequalities, right? We can play around with all of these things, but I wanted to touch base on graphing inequalities. We will go through and graph some more example problems, but I just wanted to do that really quick. Oh, I hope all of you were good, ready to rock and roll to the next slide. So let's go ahead. Solve and graph the following inequality. Are you ready? Wait. Oh, I'm going to come up with this one. That's what this is for. So let's go ahead and write out our inequality. And we are going to do 3... I'm just coming up with this from the top of my head. Actually, I have an example, and I'm going to pull that up. It might make you freak out a little bit, and I hope it does. This one is incredibly difficult for somebody that's just popping in, that is just getting comfortable with algebra. This will really make you comfortable, or it will make you uncomfortable, but let's write it out. So our problem is 6, that's way too thick, so 6r, we'll change that to x. I don't like those other letters. 164 is less than or equal to 5 all times 4 minus 3x, and end parentheses minus 2x. It looks like a horrible problem, and it kind of is if you're not comfortable with these types of things, right? But that's why all I want you to remember, don't stress. I don't want you to even think about this problem quite yet. We have our rules. We have our steps that we take to solve math problems like this. That's what you should remember. Think of the individual steps. Don't think of the whole big picture. And I know you want to. This looks ugly. But if we just take one step at a time, it becomes very easy to solve this problem. So the very first thing that we must do is distribute. Let's distribute our 5. Okay? I want to distribute the 5. And what happens when we distribute the 5? Let's go ahead and write this out. So I think I'm about the same color. So I'm going to just write out my left side as if nothing is happening. They are totally ignorant to what is happening to the right side of the inequality. 5 times 4 is 20. And what is 5 times a negative 3x? What is 5 times a negative 3x? That is a negative 15x. And then we just write our minus 2x in. And look at that. So what can we do? What can we do between these two terms? We can simplify. Simplify. Am I still on the screen, everybody? Let's see. I don't know. It's not showing up yet. I think I am. So simplify. And how do we simplify? We combine like terms. So combine like terms. Let's go ahead and we will rewrite our new problem now. The left side is still ignorant to everything going on the right side, totally oblivious. And we have 20 minus, so 15x. I'm gonna have to like erase all of this stuff and write it somewhere else. 15x minus 2x, that is a negative 17x. Okay. And I like to keep my coefficients in front of the variables, my numbers in front of the variables positive. So let's get rid of this negative 17x or this minus 17x on the right side. What is the inverse operation of a minus 17x? What's backwards from subtraction? It is addition. So let's go ahead and add 17x to the right side, and we must add 17x to the left side. And what is the left side? What does that look like now? What is 6x plus 17x? What occurs between those two? Addition. What is 17 plus 6? That is 23x minus 164, and that is less than or equal to 20. Okay. Notice how we haven't done any multiplication or division by a negative number, so we don't have to worry about flipping. Don't forget about flipping your inequality symbols if you multiply or divide by a negative number. What do we do now? Well, we want to get rid of the addition or the subtraction, and you do that through addition. So we add 164 to the left side, and we go ahead and we add 164 to the right side. We are left with 23x is less than or equal to 20 plus 164 is 183. And now we have to ask ourselves, what is 183? What is occurring between our 23 and our x? That is multiplication, so we must divide both sides by 23. And now we are at a fun part. What is 23 or 183 divided by 23? Can we do it? Do you have a calculator handy? If you do, that'd be awesome. You could answer me in the chat, because I don't have a calculator handy. Let's see. That's 140. That's 160 something. 8 is 160. 8, 16, 24. That's 184. Nope, we do not have a nice clean solution to this one. Let's just take a quick look and see if we have an answer sheet. Did I write everything down right? Everything seemed pretty good. I think we're good still. 6x minus 164 minus 2r. I combined. That's 15. That's 17. I'm double checking all of my work. So what is 8 times 23? That's 184. But, oh, look at that. Look at that. How did I get the 3? Where did that 3 come from? See? It's very easy to make mistakes like this. I mean, just as simple as this right here. We don't want a 3 there. Let's not make it extra nasty looking. Let's just go ahead and we'll blot this out. Okay? The 3 should not be 183. I was just trying to go too fast, guys. I'm sorry. What number is it? What is 164 plus 20? What's our answer there? It is 184. Okay? And what is 184 divided by our 23, that would be 8. So x equals, or not x equals, x is less than or equal to 8. And we get our final answer. So x is less than or equal to 8. What that means is if we go ahead and we plug 8 in for 6x, which I will not do a check step on this. I'm just happy I fit all of this on our one screen. But if we were to plug our 8 in for the x, everything would stay true. The left side would be less than or equal to the right side, okay? And that's where inequalities become powerful, right? Think of your, like, let's just say that you got a flat tire. You have a flat tire on your vehicle and you need to lift the car up, right? You have your car jack out and you're lifting the car up. How far can you lift it up? Well, you have to lift it up a minimum amount to get the tire off, right? But could you lift it up higher? Could you go higher than that minimum amount? Absolutely. You can keep jacking the car up. That's kind of like an inequality. There is a minimum that you must meet, but you can keep going. You can't keep going to infinity, right? Because there's limits on the height of your car, of the jack for your car. But that idea of, oh, I can keep going farther and it's still okay, might not be safe, but it's still okay. It still gets the job done. That's kind of what inequalities are similar to. One thing that I kind of think of when I think of inequalities. Let's get rid of all of this and we will move on to our next example problem. And let's hope it goes a little bit more smooth with the stream. So let's go ahead and draw a number line. And the question, something that you might get on the GED, would be something like the one above, where it's, what is, let me draw that a little bit straighter. What is the inequality shown on the number line? So we have our positive 5 and our negative 5, and then we will put a 3 right about here. And I'm going to go ahead and we're going to make this a filled in circle, okay? And then we'll draw this to the left. So what is this saying? What is the way of writing this as an inequality? Well, check your circle. If it is filled in, so filled in, it brings it into two options. It could either be greater than or equal to, or less than or equal to. And then you check your direction. So this is your first step. This is number 1. And then number 2 is check the direction of the arrow. And it can either be left or right, right? So it's still going to either be greater than or equal to, or less than or equal to. So if I'm going left, which one is it? Which one of these two? Is it that one or is it this one? Well, it is this one. We are going to the left. It is less than or equal to. So we are less than or equal to what number? 3. So what is less than or equal to 3? We don't know. So it's x is less than or equal to 3. And this is our graph, okay? We can graph any of these inequalities. Any inequality, you can pretty much graph it. Sometimes they might look a little bit weird, but you can do it. Okay, let's move on to another example problem. Let's do another graph. Why not? Let's go with a bigger one. We will still go with our same relative sizes of number line, but we'll put a 5 and a 10, and we'll put a 5, a negative 5, and a negative 10. And what if I graphed an open circle? It looks like, okay, this is at 7, negative 7, and it is an open circle, and it's going to the right. Okay, so let's do our steps. So this is step number 1. And step number 2 is checking the direction. And what is it though, right? So we don't have the number. We're not asking for a specific number. We're just asking for an area that's bigger than, or a zone that's bigger than any number that's bigger than this -7. Is to the right. The arrow is pointing to the right. It is an open circle. So is that greater than or equal to, or just greater than? Can we be that -7? We cannot. So we just write it out as x is greater than -7. X is greater than -7. We can't be -7. We can go ahead and put a circle around that one, and we're good. We're good to go. Does that help a little bit? If any of my students are watching, you know, give me like a thumbs up or something in the chat. That would be awesome. Even if this is later, you're watching this later, I would think that is so cool. If I open up my phone and I see that somebody commented just even the words thumbs up, I would be tickled pink. Oh my gosh, I sound like Ned Flanders. That's okay though. I suppose it's good to sound that way on YouTube nowadays. Here's our next word problem. They really like to word things in an unusual way on the GED. And I don't see that changing on the GED in 2022. So the product of a number and 5 increased by 3 is less than or equal to 23. So here they just want us to write the inequality. They just want us to write this. What is this saying? So it is, we'll get our different colors out. So the product of a number and 5. What is another way of thinking of the product of a number and 5? What's happening there? It is 5x. We don't know what that number is, right? So 5x, and it's increased by 3. So it's increased by 3. So we add 3 to both sides, or not both sides, there is no other side. I'm just so programmed to saying that it automatically came out. And it is less than or equal to, so we'll write the less than or equal to symbol, 23. And we'll just go with green. There. That's technically all they've wanted. They didn't ask you to do anything else, but can we do more to this? Absolutely. Absolutely, we can do more. We can solve. Let's solve this. Let's solve the problem. This would be good enough for your answer, but let's solve this problem. Okay. So 5x plus 3 is less than or equal to 23. What is our first step? We'll rewrite this down below. 5x plus 3 is less than or equal to 23. We must do the inverse operation of adding 3. Think of backwards order of operations, reverse PEMDAS. So when you say 5x plus 3, what's the inverse of plus 3? It is minus 3, and we do that to both sides of the inequality. Let's do that color. So this cancels out. And what is 23 minus 3? It is 20. We can go with white on that one. Why not? Let's go with 20, and that is less than or equal to, and then drop your 5x. So 5x. So we now have 5x as less than or equal to 20. How do we undo what's happening between your 5 and your x? First off, it's multiplication. How do we undo multiplication? What's the opposite of multiplication? It is division. So we're going to divide by 5. We want to isolate the variable. We want to get the variable by itself. So let's divide this left side by 5, and whatever we do to one side of the equation, we must do to the other side of the equation. So we're going to divide the right side of the equation by 5. The left side, 5 divided by 5, just another way of thinking of the number 1. The right side of the equation, we have x is less than, let's write that a little bit neater, less than or equal to, what is 20 divided by 5? What is 20 divided by 5? That is 4, right? Not too bad. Now, if you got to this point, how do we graph this inequality? How will we graph the inequality? So let's go ahead and do that. Nice and easy. Inequality, graphing inequalities, probably the most enjoyable graph you will ever do. And it just only takes a second. So we don't even, for the sake of it, right? When you're in school and you're studying things like this, your math teachers will probably want you to write all of your little notches, right? I mean, I know I've experienced math teachers like that, but in reality, you really don't need to. You just need enough information to get your point across. So let's just put a 4 here, okay? And remember our 2 steps that we were talking about earlier? Our first one, let's check, like, can we be 4? Yes, we can. It is x is less than or equal to 4. So we can be the number 4. So we put a filled in circle above the 4 here. And then what direction? Oops, sorry about that. What direction can we go? Or what direction do we need to go with this inequality? We need to go to the left. We need to go to the left. This is the graph. The graph is done. Okay, we found our solution. We could check step. We could do the check step, right? I don't know how many of you would want me to do the check step, but it's pretty easy. All you have to do is just make sure that it's less than so it has to be less than 4, right? Whatever number you want to pick, it does not matter. If you want to put 0 in, if you want to put 1, 2, or 3, or 4, it should be either less than or equal to 23 when you go back and you do your check step. It's pretty nice. Okay. Everybody okay with these things so far? No? Everybody's cool. Okay, great. I have no questions in the chat or nothing. It is silence in there, and that's okay. That's the benefit of streaming this type of stuff. You can just hang out and listen to the math. But if this is helping you at all, please, if you're going to communicate with me anyway, hit the thumbs up button. That'd be really cool. That would be awesome. You can hit the thumbs up button, you can subscribe, or you can just hang out and you can lurk and watch me do math. I'm totally fine with whatever you want to do. No pressure. Let's move on to our next example problem. Okay, I know. It's a word problem, and everybody hates word problems because it causes that anxiety. You don't know whether it's going to be difficult or not because you can't see it. It's just the words, right? But I promise I did not do a difficult word problem for you today. So John has $15 and Billy has $22. Together, they have less than the amount needed to buy a pair of concert tickets. Write an inequality that describes their situation. Oh, I wonder if my cat's going to make another appearance in this stream. We will see. Oh, I have to sneeze. Okay, so $15 and 22. Sorry about that. So, what do? Well, together they have less than the amount needed to buy a concert ticket. Do we know how much the concert ticket is? We do not. We do not. So it is less than. You gotta get out of here, Spot. Please leave. I'm asking you kindly. Okay. 1 second. Hang on. Let me get rid of the cat. Okay. That cat has been loving to make appearances on the stream lately. So, we have John has $15, Billy has $22. Together they have less than the amount for the ticket. We don't know what the ticket is, so we're going to put that as X, okay? And they have less than that amount. So let's go ahead and we add, because they are together, it's 15 plus the $22. And what is 15 plus 22? Let's write this out in a straight line for you all. So 15 plus the $22. What is it? It is $37. And this is less than the amount for the concert ticket. So what's another way of thinking of it? So here is our inequality. Okay, this is a good tip for the GED. On the GED, they will write inequalities this way. And for some reason, it really bothers me a lot. I can understand it, right? And all of the other examples that we've done today, inequalities are written the other way, where the variable is out front. And it makes it very nice and easy. There is a way to always make your variable out front. So let's just do that with this example. Let's just say I want to have my X be the number on the left. How do we do this? Well, you have to flip the entire inequality, right? You want to flip it like a pancake, right? So you put your spatula underneath, you flip the whole thing. And this is the same as X is greater than, so what I'm looking at is this open mouth and the direction of the open mouth, right? It's kind of like Pac-Man. Okay. What is Pac-Man eating? Pac-Man is eating the X, right? So Pac-Man still wants to eat the X no matter what. If I want to write this a different way, it must eat that letter. And $37. So to me, this is the proper way of writing an inequality. You should lead with your variable. They will show this on the test, on the GED. I am 100% confident you will get problems like this. But that's it. That was it. Very straightforward. So now that we have written it out with the variable out front, let's just go ahead and graph this inequality. So we'll switch it to yellow for a nice fun graph color. And we have our 0. I always like to make sure we have our 0 so we know which side is negative, which side is positive, but you can get negative money. You can have debt. Don't forget about that. So we will put, let's go with, we'll go with 40 right here. And we'll say that this line right there is 37, okay? So that is going to be our 37. And is it an open or a closed circle? Can we be 37 in this inequality? This is what I'm checking. Remember, check your sign first. That's your first step. So what you do, it's not. You cannot be 37. So it is an open circle at 37, and then what direction are we going? So in this example, it is to the right. So now it's not that this is how much money they have. This is how much money they have combined. Their money. Right? All we know is that they don't have, so this line right here, right, our X is they have less than the amount needed for the ticket. Do we know how much the ticket is? We do not know how much the ticket is. That's why, so somewhere above $37. It costs somewhere above $37. That's the only thing we know. That's the only truth, the only fact of this word problem that we know for certain. And that's the graph for it. So it goes to the right. I'm a little bit off of the screen, but that's okay. All right, let's move on. Oh, that's my last normal example. We are now going to move into, I want to do some challenging, difficult, algebraically intense examples of inequalities, because the more you do inequalities, the better you'll get at algebra and inequalities. It's a really high return rate for your time. The big things to remember, I will put up in the corner here. So this is our note for however long we do these inequalities. Our note is, oh, we don't need that up. We're going to add another layer here. Okay, so our note, and that is if you multiply or divide, or divide by a negative number, you must flip the inequality. If that's the only thing you remember with inequalities, you are doing a-okay. So by a negative number, you must flip the sign. Flip the sign. Okay. And a couple of exclamation points. There we go. Okay, so you must flip that sign. Now I'm going to bring up some of our example problems, and they are big and beefy, okay? So our first example problem of the intense, algebraically intense set of numbers, we are going to go with negative, I'm going to write this as far up and in the corner as possible. So we will go with negative 5g minus 6 plus 6g is greater than or just greater than negative 11. Okay, and we will graph this too at the end. We will go ahead and we will graph this. Before we get going, and I know this is going to be punishment for some of you, before we get going through this process, if you are enjoying this or if you're learning even a tiny bit, please give that thumbs up a hit the like button, because then we can help more people, right? More people will get help with inequalities if you hit the like button. So you're actually doing a really awesome service for not just me, but anybody else out there. So let's go ahead. The very first thing we are going to do is I'm going to combine like terms, because on this problem, it's very nice. Everything is on the left side. All of the stuff we really are worried about at the moment, it's on the left side. So we have our 5g, or negative 5g, and our 6g. So what happens when we combine them together, right? What is 6g plus 5g? Well, that is going to be just 1g, right? Just a g by itself, a lone g, minus 6, and that is greater than negative 11. Okay, so how do we get rid of our minus 6? What is the inverse operation of a minus 6? It is a plus 6. Okay, whatever we do to one side of the equation, we must do to the other side of the equation. So we're going to add 6 to the right side. Minus 6 plus 6 cancels out into a 0. We don't have to worry about that, because g plus 0, it's just nonsense, right? Like it's not plus anything. We don't need to write it. And on the right side, so we have g is greater than, and then negative 11 plus 6. What is negative 11 plus 6? You have $11 of debt. Okay, think of it like that. You owe somebody $11. I come up I give you $6. You're like, oh my gosh, thank you so much, Paul, for the $6. I'm gonna go pay off my debt with this. And you go to the person you owe money to, you give them the $6, and they're like, hey, you still owe me money. How much money do you owe them? You still owe them $5. You still owe them $5. So it's a -5 on the right side. So G is greater than -5. How would we go about graphing this? Let's go and we'll change to our nice yellow color for our graph. So we'll label it as the graph. And we put our arrows. This means that it's stretching out for infinity. And we put our 0 in the middle and our +5 on the right, our -5 on the left. And where are we at? We are at -5. Can we be -5? No, we can't. We cannot. Remember, this is your first step, is to check the sign, and the second step is to check the direction, right? So we're going to put an open circle above our -5 because that's what we are at. And then, is it going right or left? So whenever you have that letter in front, you can do this. You can just check what direction that sign is going, and that is going to be the way you draw your line. It's super nice. So this is the graph for our inequality. Boom, we're done. Easy peasy lemon squeezy. Let's go ahead. We're done with that one. And I'm gonna just keep doing this for a little bit. If you guys want to hang out, I greatly appreciate it. This is actually quite a bit of fun. It is not too bad. I enjoy doing these types of things. We are going to move on to our next problem, which is we have our -2s plus 5s is less than -72. Okay? Here, what do we have? Do we have anything really confusing here? Absolutely not. -2s plus 5s, combine your like terms. So combine like terms. Combine like terms. What is a -2s plus 5s? That is 3s, and that is less than a -17. Okay, so what is our end answer here, right? So we have 3 times the s, so we must do the opposite of 3 times the s, and we must divide it by 3. Do that to both sides. Your left side will cancel out. That goes down, simplifies down into a 1, and 17 divided by 3. Oh boy, we're gonna get a fraction. So s is less than, let's think, let's go through this together. How many times does 3 go into 17? Count it out on your hands if you have to, right? So 3, 6, 9, 12, 15, it goes in there 5 whole times. If we do one more, it's at 18. We can't be 18, we can't be more than that. So it is a -5 wholes. And how much do we have left over? We're at 15. So we have 2 left over. So 2/3. So s is less than -5 2/3. If we were to graph this problem, we would have our 0, and this time I'll add a little bit more room. So we have our +5 and our -5, and we'll just say that this right here is -6 because we need to be in between those 2 points. So -5 2/3. We have our dot right about, is it an open dot or a closed dot? Can we be -5 2/3? No. So it is an open dot at -5 2/3. And then what direction do we go? left or right? Left. Because our variable is first. That is the only reason that trick works, okay? So if you might have to go back to earlier, write that down. You can flip the whole thing and always make your variable first, okay? But we're going to drive this to the left. Boom. That's our graph. We're done. Easy as pie. Let's get rid of that. And let's see. Let's go ahead and I think, hey, oh, I'm sorry. Export. I hope that, okay, so does the inequality appear on the non-calculator part of the exam? Yeah, so your non-calculator part of the exam, it's like the first 5 questions. I hope that you're still around. Man, you commented. That is so cool. Okay, so there is a very high likelihood you will have an inequality in the non-calculator part. It's your first 5 questions, okay? Let's see if I can remember. It's been a while since I gave my initial lecture for how many questions are on the math test. I want to say, have you taken a math practice test by any chance? Good, you're still here. If you've taken the math practice test, your actual math exam is about twice as big as that, okay? That's the good rule of thumb, is whatever that math exam was, that math practice test, it's twice as big. And I want to say it might be like 40 to 45 questions, okay? And yeah, the first 5 questions are non-calculator. You can't use your calculator. And then on top of that, the most common thing I know of on the first 5 parts of your questions are rational algebra problems, right? We can go over those. If you don't mind saying, when do you plan on taking your GED test, your math test? Do you have it scheduled already? Let's see. I might have a big delay. I think I can change my delay though. I just changed my latency. So, oh no, I can't change it on this one. Interesting. That's okay. Anyways, this right here, inequalities, graphing inequalities, is going to help you out. The graphing and solving inequalities, if you focus really hard on this for a little while, that will really help you out. And then the quadratic equations, dealing with quadratic, factoring, polynomials. Those 3 things are the big 3 things I would stress. And then just getting a little bit comfortable with your fractions, and then you're pretty good to go. But if you can do solving and graphing inequalities, you're good. If you can factor polynomials, you're good. I have seen next month, hopefully. Good luck with that. Yeah, that's really awesome. Yeah, the first few questions, I've seen some really nasty irrational problems. We can go ahead and instead of doing an inequality, I really want, since I have you here and I can show you these things right now. Let me go ahead. This is one of the most common problems I've had students tell me about, that they see, that like one of those first questions that they'll see on the GED math test, and that's rational expressions. Okay, so let's go ahead and write that down. Not that. Oh my goodness, crazy messy there. So add a new layer. So rational. We're moving from our inequalities for a second. So rational expressions. Okay, this your non-calculator part of the math test. It will have this. This is like people's kryptonite when it comes to non-calculator questions. This is what causes a lot of anxiety for a lot of people because they are so ugly, okay? Before we talk about rational expressions, like, let me show you why they can look so ugly. And it's all because the problem, the prime suspect, the main problem is the number 1. And you might be thinking, that's weird, Paul, right? It's like, man, it's just the number 1. But the main problem, it is the number 1. How many different ways can you write the number 1? Well, we have 1. We have 2 over 2, right? That's 1. That equals 1. We have 3 over 3. Yeah, that also equals 1. But you also can write it as x over x. This is where people start to feel a little bit uncomfortable, right? That also equals 1. You can also write it as x plus 1 over x plus 1. That equals 1. See how nasty? I can write anything. I can write anything. X squared plus z to the 10th power divided by x squared plus z to the 10th power. That also equals just the number 1, right? That right there is ugly, right? Like later on as you get through those, that's why these rational expressions can get so gross, right? Let's go ahead and erase this. Hard erase, not that one. There we go. And we'll do like 1 or 2 example problems of rational expressions, and then we'll call it good, because I'll save this as a full-on class, okay? Because you really should have the big meat of this. So let's just do, here we go. So we have, this is our question. So we are given, where is my pen? There it is. We are given x plus 2 all over 4x squared plus 5 all over 6x, okay? And then they ask us what is the lowest common denominator, right? So what is the LCD of this problem? The LCD, your least common denominator. I haven't done any videos for a while on fractions. So your lowest common denominator, you want your bottoms to look the same, right? So if we were simplifying this expression, we have to make our bottoms look the same. And this is the question I have my students ask themselves. So here's our question right over here. So what can I multiply? I'm almost off the screen. Multiply 6x by to turn it into 4x squared, okay? So we must multiply 6x by something to turn it into a 4x squared. Well, we can't turn a 6 into a 4, right? That's where things can kind of get a little bit weird. But we can turn this x into an x squared very easily. And the way that we do that is we multiply it by x, right? So x. Now, just like with our equal sign before, we must multiply both the bottom and the top by this x to maintain itself. Because what is this? Look at this. What is the other way of thinking of this? It's the number 1. We're just multiplying by a really ugly looking number 1. Okay? So let's just rewrite this problem now. So we have x plus 2 all over 4x. I mean, it looks so ugly. I'm sorry. But 5 times x is 5x all over 6x squared. So we're getting closer. We're getting warmer to making it look like this, right? But so now it's just like any other regular fraction or adding together fractions. We can change this one around and this one around. Do you know what number we should multiply? Like, what number should we be shooting for? What's the number that we want to get to with this? What's the lowest common denominator? So this is what I'm asking. What is the LCD? What is the LCD of 4 and 6? Okay, so what is the lowest common denominator? What number do they both go into? The lowest number they both go into. Can you tell me that, Bort? Are you still there? Export, yeah. Let's see. I'll give you a couple of more seconds to think on it. The lowest number that both 4 and 6 can go into, it is 12. Okay? 12 is the lowest number that both 4 and 6 can go into. What do we have to multiply the 4 by to get 12? 3. Change it into a fancy 1. What do we have to multiply the 6 by to get 12? 2. Change it into a fancy looking 1. And then you have to multiply. So now our bottom, so this is really the answer to this, is 12x squared. So this would be your answer. That's the least common denominator of this fraction. Good job. I got the 12. Nice. So what if we wanted to rewrite this whole nasty looking thing? I don't know if we should even do it. I don't have a lot of room. And if I try to do it, this is what they asked you. If they just ask you what the LCD is, that's the answer, right? No calculator needed. The math was actually easy, but it looks really bad. And that is one of the biggest issues people have with math is like, I refer to it as math anxiety. People freak out when they see rational expressions because there's all of these letters on the screen and you're just like, that's gross, I don't want to do it. But it's just fancy looking ones. That's all it is. There's a lot of fancy looking ones all over the place. If I were to go through and mark on this screen how many number ones I have a 1 right here. I have another one right here, so this is number 2. And then I have number 3 right there. So we have 3 weird looking ones on the screen. That's why rational expressions are so nasty, right? But I think we'll only do one. I'm either going to do a 10-minute video, 10 to 15-minute video giving a good introduction and getting everybody comfortable with rational expressions, and then I'll do a lesson. But either way, ooh, sorry about that. And then export, I don't know. Ooh, I think I'm getting sick. Definitely need to work on those for sure. Seems a bit confusing at first. It's really confusing at first, yeah. But if we work on that together, you'll be okay. Whew. Definitely getting sick. But if you haven't checked out my Facebook page, it's Tutor You Services, just like my YouTube name. And go ahead and hit a like on there. You can message me on my Facebook page if you need any extra help. Yeah. Yep. I taught adult education for 3 years. Absolutely loved teaching, and because of a series of events, I do not teach anymore. I don't teach at that school anymore. I still teach people. I tutor, but I can help you out. Just shoot me a message on Facebook. I can point you in the right directions to get some good example problems. So yeah. Let's get you going on the math GED. Definitely hit me up on there. But we will call it good there for the day. It is 10:30 a.m. Central Time. So hope you guys have a good day. I appreciate you watching, and I'll talk to you later. Take it easy, Export.